वो नॉइज की दिक्कत हो रही है इससे।
किसे प्रॉब्लम हो रहा है?
यस सर।
बताओ, ठीक है?
फिर चालू हो गया।
हाँ,
फिर से चालू हो गया।
किसे चालू हो गया?
अभी बंद हो गया।
अब सही है?
यस सर।
ठीक है। अब is it okay now?
यस सर।
Okay, so we'll discuss rotational spectra first. SP means spectra, and this is also known as microwave spectroscopy. Why it is called microwave spectroscopy, I will tell you. And the range of microwave is 3 into 10 to the power 10, right? 10 to the power 10 to 10 to the power 12. Of course, that this is the frequency, so it is in hertz. Then we'll discuss about vibrational spectroscopy. This is known as IR spectroscopy, infrared spectroscopy, and this range from the frequency of IR is ranging from 3 into 10 to the power 12 to 3 into 10 to the power 14 hertz. Then we'll discuss about electronic spectroscopy. And this is the combination of visible and UV part, ultraviolet part. Okay, and the frequency range of UV and visible is 3 into 10 to the power 42, 3 into 10 to the power 16 hertz. Okay, and finally we'll discuss about NMR and ESR spectroscopy. And this is basically known as radio wave spectroscopy. And the frequency range of radio wave is 3 into 10 to the power 6 to 3 into 10 to the power 10 hertz. Okay, why it is called rotational spectroscopy is called microwave, vibrational is called IR, electronic called visible and UV, and NMR. NMR means nuclear magnetic resonance. ESR means electronic spin resonance, and this is basically known as radio wave spectroscopy. And frequency range, basically rotational spectroscopy is found in this range. Why it is found in this range, I'll tell you. Then vibrational spectroscopy is found in higher range, and the frequency range is mentioned here, that is 3 into 10 to the power 12 to 3 into 10 to the power 14 hertz. Then electronic spectroscopy, this is basically found in visible and UV range, and the frequency range is 3 into 10 to the power 14 to 3 into 10 to the power 16 hertz. Okay, so every details why it is found in UV visible and why it is rotational is found in microwave, everything I'll tell one by one. And finally NMR and ESR, this is basically found in radio wave region. Okay, So this is the course details. Okay. So let me define, before going to rotational spectroscopy, let me define types of molecule. Okay. So first is linear molecule. Okay. So linear molecule example is HCl, CO. Okay. Then you have CO2. So in this, if you draw the structure of HCl, this is H and this is Cl. Okay. Let me expand the bond length. Okay. And let me define the axis. Suppose this is your Z axis, this is your Y axis, this is your X axis. Okay. So this, let us assume this is the axis of rotation, and there are maybe three kind of axis of rotation. This rotation axis, the rotation along X axis. So let us assume the moment of inertia is Ix. Okay. And along this, the moment of inertia will be Iy. Along this, the moment of inertia will be I. So what is the form of moment of inertia? How we will calculate that moment of inertia? I equals to sum over I mi ri square. Mi ri square, right? So where ri is what? Ri is the perpendicular distance from axis of rotation. Axis of rotation. Okay. So in this case, if we can clearly see along Z axis, this is the origin. Okay. Perpendicular distance from the axis of rotation. So in this along Z axis, what will be the moment of inertia?
0.
0, right? Everybody agreed? So because along Z axis, the sum over mi ri square, right? So ri will be 0 for this as well as this, right? Because this is your axis of rotation. So if this is the axis of rotation, so the mass will be on the axis of rotation, right? So mi will be something for Cl and H, but ri will be 0 because ri is nothing but the perpendicular distance from the axis of rotation. And if you are taking that Iz, the mass is basically locating at the axis of rotation. So ri will be 0 when you will take Iz. But when we will take Ix and Iy component, let us assume this is the axis of rotation. So molecule is rotating about this axis. How much the value will get when the molecule will rotate along y-axis? Okay, so we'll get same value because if it is rotating along y-axis, this distance and this distance will be fixed. So whatever distance you will get for rotation along x-axis, it will be exactly same when it will go rotate along y-axis, and there is no change in that r value, and m is same. So what you can say for linear rotation or linear molecule, Ix equals to Iy and Iz will be 0. Is this part clear?
Yes, sir.
Is
Yes,
this
sir.
part clear to all? Is this part clear to all?
Yes.
So when you are taking along z axis, your r will be 0. So that's why moment of inertia will be 0. But you are when you are taking x axis, this will be the r1. Let us assume. So m1, let us mass of Cl is m1. m1 r1 square plus, let us assume this distance is r2 and mass of hydrogen is m2. So m2 r2 square. When you will, when the molecule will rotate along y-axis, okay, distance will remain the same. So it will be r1 as previous case, and mass is same. So there will be no change in distance. So that's why Ix will be equals to Iy and Iz will be 0. Okay, next is symmetric top molecule. So this is that is not important for your net, but since we'll go that important topic and real interesting topic like rotational vibrational spectroscopy, you have to know these things also. Next is your symmetric molecule. Molecule. So for example, CH3F, CH3Cl. Okay. So in this case, you have C. Okay. This side you will have Cl, then H will be like this. Along X, this is your Z axis. This is your X axis. This is your Y axis. So in this case, Ix equals to Iy. Moment of inertia along X axis equals to Iy, but it will not be equals to Iz. But Iz will not be 0 here. Okay. And there are two cases on if Ix equals to Iy and that is greater than Iz, this is known as prolet. And you have second case, if Ix equals to Iy but less than Iz, that is known as oblet. Okay. Next you have spherical top. Example, CH4, Si, SiF4, H4, okay, and so on. So in this case, Ix will be equals to Iy and it will be equals to Iz. So if you draw that structure of CH4, it will be okay. And last part is your asymmetric molecule. Okay. Example, H2O, NO2, and so on. In fact, most of the molecule are basically asymmetric. Okay, if you draw H2O, it will look like this. This is your O. Sorry. So these are the type of molecules. So molecule can be differentiate into 4 types based on their moment of inertia. Okay. Now we'll go to the spectra, rotational spectra, and this is really important, interesting. So shall I erase now?
सर
Yes.
प्रोलेट ऑबलेट मतलब शेप्स चेंज हो जाते हैं ना मॉलिक्यूल्स की, ऐसा कुछ है क्या?
मॉलिक्यूल का शेप नहीं यहाँ पे, हाँ जो आपका ओरिएंट अरेंजमेंट है ना उसके ऊपर डिपेंड करेगा। प्रोलेट के लिए क्या होगा आपका, जैसे न्यूक्लियर फिजिक्स में पढ़े हो वो बात अलग है। यहाँ पे मोमेंट ऑफ इनर्शिया एक बेस पे है। अगर एक्स आई एक्स कंपोनेंट ऑफ मोमेंट ऑफ इनर्शिया वाई कंपोनेंट के बराबर है and that is greater than Iz, then it will be called prolet. Okay, and it basically depends upon that structure of molecule. Okay, so there are various type of structures of molecule in symmetric top itself. So some of them, for some of them, Ix equals to Ii but greater than Iz. For them, this is called prolet, and for some of them, Ix equals to Ii but less than equals to Iz, and this is oblet. It depends upon that structure of your molecule. Let me go to rotational spectra, and that is really important and interesting also. So as I told you that rotational spectra is microwave active or microwave spectroscopy also. So let me write rotational spectra of linear, rigid, diatomic molecule. Okay, so this is also known as a rigid rotator. Now suppose you have molecule HCl. Okay, so this is positive and this is negative, right? This is H plus Cl minus, right? So you
Yes,
have
sir.
there is a polar nature, or you can say there is a permanent dipole moment on this molecule. Okay, when you expose microwave, then what will happen? It will start rotating with same frequency of incident microwave. Okay, so it will start rotating, and the frequency of rotation will be same as your incoming EM wave or incoming microwave. And you know, rotating dipole will create or will emit radiation having same frequency as frequency of rotation, and rotation frequency is same as frequency of incident microwave. So what you can say, this molecule will emit, or this rotating dipole will emit radiation having same frequency as incoming microwave. So I'll draw a picture, then it will be clear how that molecule is basically rotating. So let us assume a capacitor. Okay, capacitor, inside capacitor you have kept this molecule. So this is, let us assume this is H plus, and this is minus, Cl minus, H plus Cl minus. And I am connecting this capacitor to a source of external source of microwave. Okay. Then what will happen in first half cycle? This plate of capacitor will be positively charged, and this will be negatively charged. Then what will happen? This is a positively charged plate capacitor is positively charged. So what will happen? This charge or this pole will be reflected, right? Similarly, this plate is negatively charged. This is negatively charged, so it will be again repel, right? So in first half cycle, what will happen? Due to same polarity, it will rotate. In next half, so after rotation, what will happen? Second scenario will be, now in next cycle, this will be negatively charged, this will be positively charged. And this pole will go to here, this pole will come to here due to rotation. So next scenario it will be, so now again similar charge it will repel. This is also similar charge it will repel. Again it will start rotation. Okay. Next cycle it will again positive, it will be negative, and due to its rotation, this positively charged will come here for pole, and negatively charged will come here. Again there will be rotation. So see, due to this rotation, when a dipole will rotate, it will emit EM radiation, and that frequency of this emitted radiation will be same as frequency of rotation, and that frequency of rotation will be same as frequency of incident microwave. Okay, so for like this is the way how that rotation used to happen. So for microwave, that molecule should have permanent electric dipole moment. But you see, according to classical mechanics, this dipole can absorb continuous incoming frequency. So it means it can emit, or it can get, the emitted frequency will be continuous in nature. So if you see that intensity versus wavelength, according to classical mechanics, the spectrum should be like this. Along y-axis you have intensity, along x-axis you have wavelength. But this particle is subatomic in nature, so obviously it will not follow quantum classical property or classical mechanics. So this property will be governed, since this is subatomic particle, so the property will be governed by quantum mechanics. So according to quantum mechanics, the spectrum should not be continuous in nature, but it will be discrete in nature. So I'll prove that. So before that, for rotator, can you please tell me what will be the Hamiltonian?
Sir, LZ square by 2I.
So let me take that rotational operator J square, so it will be J square by 2I. Okay. Now I don't know I. Let me define I. So shall I erase this part? Is this part clear to all?
Yes, sir. Sir, 1 minute, sir. Sir, it is only applicable for when this AC source is in microwave frequency.
Exactly. That I'll tell when I'll derive it. Why this is called microwave? These things will only happen in microwave. So when you will apply that frequency 3 into 10 to the power 12 to 3 into 10 to the power 14 hertz. 10, right? 10. 10,
Yes.
10 to
10
12.
12.
Okay. If you apply above this frequency, it will not rotate. जैसे मैं आपको एग्जांपल दूंगा, अगर कोई आपको बोले कि एक सेकंड में एक बार रोटेट करके दिखाओ, आप दिखा पाओगे? अगर कोई बोले आपको 1 सेकंड में 1000 बार रोटेट करके दिखाओ, नहीं दिखा पाओगे ना.
Yes, sir.
Okay, so this is the thing, but yes, I'll tell at the end, I'll tell why this is called microwave active, why this is used to happen in microwave. But let me derive. Is this part clear? What I told, is this part clear to all?
Yes, sir.
Okay, shall I erase this part?
Yes, sir.
Okay, so let me define. Suppose again I'll take some molecule, but that diagram will be little bit long. So this is your H, this is your Cl. Let us assume that bond length is R naught. Okay, bond length means this distance from the center of H to center of Cl, that is R naught. And the axis of rotation or center of mass will be where? Will it be at middle? Center of mass, will it be at
No,
middle?
sir.
No.
No,
It
sir.
will be towards
Yeah.
To the
vector
seal.
element, right?
Yes, sir.
Right.
Seal.
So
Yes, sir.
this is your axis of rotation, or you can say center of mass axis. Let us assume the mass of this fellow is m1, this fellow is m2, and this distance is r1, this distance is r2. Okay, then what will be the moment of inertia about this axis of rotation? Okay, what will be the moment of inertia? So it will be I equals to how much? m1 r1 square plus m r2 square, and it will be mu r naught square. How will prove? Can anybody prove this? Mu equals to, where mu equals to reduced mass, that is m1 m2 divided by m1 plus m2. Can anybody prove from here to here?
R1 plus R2 is equal
Yes,
to
sir.
R0.
Yes, sir. So M1 R1 equal to M2 R2.
Exactly. So for this, since this is the origin, so what you can write? m1 r1. Please tell me if you have any further doubt. m1 r1 equals to m2 r2. And also you know r0 equals to r1 plus r2. Now you can replace r2 in terms of r0 and r1, right? So if you replace, how much you'll get? So m1 r1 equals to m2 r0 minus r1. So it will be r1 will be how much now? m2 r0 divided by m1 plus m. दिखाई दे रहा है ये पार्ट? Similarly, is this part clear to all? कहीं पे कोई डाउट है यहाँ पे? अभी बताओ, नहीं तो मैं पूछूंगा फिर. Is this part clear? Similarly, you can write r2. r2 will be m1 r0 divided by m1 plus m. Now if you substitute this r2 and r1 here, you will get this. Okay, is this part clear? Why I am writing this?
Yes, sir.
Because this is the origin. So what you can write? Center of mass equals to m1. It will be minus m1 r1, right? Because this is the origin, so this side will be minus m1 r1. So you can write minus m1 r1 plus m2 r2 divided by m1 plus m2. Okay, and r, I have assumed this is 0, but or origin, so you can write 0 equals to this. So from here you can clearly say that m1 r1 equals to m2 r2. Okay.
सर आर नॉट की वैल्यू R1 माइनस R2 नहीं होगा?
नहीं, आर नॉट का वैल्यू नहीं, ये आपका लेंथ टोटल मैग्नीट्यूड लेना पड़ेगा ना, मैग्नीट्यूड लेना पड़ेगा ना, लेंथ मेजर करो आप। नहीं, ये वेक्टर फॉर्म में नहीं है।
ओके सर।
हाँ, आर नॉट विल बी टोटल डिस्टेंस, यहाँ से यहाँ टोटल कितना डिस्टेंस, ठीक है। सपोज मान लो आपको कोई बोले ये ओरिजिन है, इसका कोऑर्डिनेट R1 है, सॉरी इसका कोऑर्डिनेट R2 है और इसका कोऑर्डिनेट -R2 है, R1 है, तो कितना डिस्टेंस होगा?
R2 माइनस ऑफ R1।
माइनस ऑफ माइनस R1 ना, प्लस R1 हो जाएगा ना ये,
ये सर R1 प्लस R2।
R1 प्लस। ओके, शैल आई इरेज?
यस।
Yes, sir.
Okay. Okay. So this is your Hamiltonian, right? Now, by using Schrodinger equation, what we can write? H psi equals to E psi or EJ psi. So H is how what? J square, but by 2I psi equals to EJ psi. So when that J square operate on this, so what you will get?
J into J plus 1 expected.
Exactly. So you know this part, right, from quantum mechanics itself. So it will be J into J plus 1 H cat square divided by 2y. Here J is rotational quantum number. Rotational quantum number, okay. And J can take value from 0 on 2, 3 and so on. Okay. So this is your rotational energy. Okay. So in terms of wave number, in terms of wave number, epsilon j, for wave number epsilon j is what? Energy Ej by Hc.
H.
Ej by Hc. So then how much you'll get? So H square by, I break H cross. I have written H cross here. So if you write in terms of H, it will be H square by 8 pi square I. And you have divided by Hc. So finally it will become H by 8 pi square Ic J into J plus 1. And that unit, of course, it will be in semi-inverse. So in terms of wave number, it will be like this. Okay. Now, epsilon j will be B j into j plus 1, semi-inverse, where B is what? B is H by 8 pi square Ic, right? So you can clearly see this is B is known as rotational constant. Rotational constant. Okay. So you can clearly see that B is inversely proportional to the moment of inertia of molecule. So what you can write from here? B is inversely proportional to I is what? Mu r square, right? So you can say reduced mass. This is very important for your exam point of view. I'll do many problem by using this formula. Okay. Shall I erase down part?
Yes.
Okay, so this is your B, rotational constant. Now B, if you plot that energy diagram, so the energy level will be looking like this. So we have this epsilon j equals to B j into j plus 1, right? Okay, so j, this is j equals to 0, 1, 2, 3, 4. That energy will be 0, 2b wave number, 2b. Then you have 2 into 3, 6b, then 12b, then 20b. So this is the energy level diagram. So ground state will be 0, then 2b, 6b, 12b, 20b. Okay, and this is your j. So now if suppose you sign a microwave, if you sign a microwave, the wave number of corresponding microwave wave is matching with the energy separation between first two level. Then what will happen? It will absorb the molecule that is at the ground state, it will absorb and it will go to first excited state. Okay, so for this wave number of this molecule should be 2b. Okay, and again for transition, rotational transition, that selection rule is always delta j equals to plus minus 1. I mean that if you sign that photon having large energy, it cannot jump from here to here. It can jump from 0 to 1, it can jump from 1 to 2, it can jump from 2 to 3, 3 to 4. Only one step it can go. Okay, so that is the selection rule. Now what will happen? After absorbing this microwave, it will immediately come back and you will get emitted photon having wave number 2b. If the incoming photon having energy that is matching with this gap, 6b minus 2b, 4b, then molecule at here, it will jump from here to here, and after some time it will come back. So it will emit photon having wave number 4b. Similarly, if the wave number of incoming photon is matching between these two gaps, molecules from here, it will go to here, and it will come back. It will emit photon having wave number that is separation between these two levels. Okay, and similarly from here also you will get. Okay, so if you see that emission spectrum, you will get this is your wave number. Okay, wave number versus plot. That I'll come to that plot, but at least you have seen that 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 molecule cannot jump from one step to another step. It can go. It can go from 0 to 1, 1 to 2, 2 to 3. Okay, but it cannot go from 0 to 2. Okay, now that wave number of emitted photon, let us assume that J prime is the rotational constant of upper level. Okay, and J double prime rotational constant of lower level. Then what will be the wave number corresponding to the transition? Wave number of the emitted photon. What I am saying, you have energy.
सर
Yes.
ये जे एंड जे डैश आप एक बार बता सकते हो मेरा
हाँ,
connection
जे
चला गया था।
डैश मैंने अज्यूम कर रहा हूँ कि अपर लेवल का आपका रोटेशनल क्वांटम नंबर है। जे डबल डैश जो है लोअर लेवल का रोटेशनल क्वांटम नंबर है। आपका जो ट्रांजिशन हो रहा है अपर लेवल टू लोअर लेवल, इसमें आपका फोटोन इमिट हो रहा है, तो इमिटेड फोटोन का वेव नंबर क्या होगा, कैसे निकालोगे? तो अपर लेवल का जे प्राइम है, लोअर लेवल का जे डबल प्राइम है, then wave number of emitted photon, let us denote that is nu bar, will be what? The wave number separation between upper level and lower level. So what I can write? Epsilon j bar minus epsilon j double bar. And selection rule, according to selection rule, j bar minus j double bar should be equals to +1. Right? Is this part clear? Now we'll substitute that epsilon j. So it will be B will be common, j bar plus 1 minus j double bar double dash j double dash plus 1. Okay. Now in place of j dash, I will write j dash equals to 1 plus j double dash. So if you substitute it here, so you'll get B into j double dash plus 1 into j double dash plus 2 minus j double dash into j double dash plus 1. Okay. Yes. Sorry, your voice is not clear.
plus 2 again.
Your voice is not clear. Can you please write what are you saying? Your voice is not clear. Your voice is not audible. Can you please repeat once more? Okay. You can write me. I'll tell you. So if you solve it, then wave number of emitted photon will be how much? So if you see j double dash j double dash j double dash j double dash square, here also you have j double dash square. It will be cancelled. From here you will get 3j double dash plus 2, and you have one j double dash here. So finally you will get 2j double dash plus 2. So if you take 2 common, then wave number will be nu dash will be twice b. Yes. Yes. You have question? Second term from first bracket. Yes. Here I am substituting in place of j dash. I'll substitute 1 plus j double dash. Okay. So 1 plus j double dash, if you substitute in place of j dash, so you already have 1 plus 1 2 plus j double dash, and first term j double dash plus 1. So I am using this selection rule because delta j is plus minus 1, and since I assume that j double dash is upper level quantum number and j double dash is lower level quantum number, so obviously this subsection will give you plus 1. Is not it? Because this is high as compared to this. So while substitute 1 minus 0, it will give you plus 1 itself. I have used this facility to come to the number, that is 2b into j double dash plus 1. So j double dash is the lower level quantum number, right? So I can use that notation in place of j dash. I will use simply j. So it will be 2b j plus 1. So now let us assume your transition is happening from 0 to 1. Then what will be the nu bar? What will be the nu bar? Simply here I will use what? 0, right? Or 1 to 0. Sorry. Transition is happening from 1 to 0. Then it will be 2b, right?
Yes, sir. 2.
Similarly, if transition is happening from 2 to 1, then it will nu bar will be what?
4.
In place of j I will write 1 because it is lower level, right? So lower level here 1, so 1 plus 1 2 into 2b, that will be 4, right? If transition is happening from 3 to 2, then it will be new bar will be how much? So here it will be 2, 2 into 2 plus 1, 3, 3 into 2, 6, it will be 6. Okay, so here from 1 to 0 it is happening. So that corresponding wave number is what? 2b. Of course, new bar here in semi-inverse. So emitted photon will have wave number at where? At 2b. Second will be at 4b when transition is happening from 2 to 1. Third will be at what? Plus 6b. Right? Then you will have, is not it? Then you will get at,
सर सेम इंटेंसिटी भी होगी सर?
no, that will come. Intensity will not be same. It's a good question. Intensity will not be same. I'll come to that. Intensity will be same at somewhere at intermediate. It will not be same here. It will not be same here. I'll come. Very good question.
सर y एक्सिस में क्या है?
सर
प्लॉट
Y एक्सिस में आपका इंटेंसिटी है. जब भी कोई स्पेक्ट्रम ड्रॉ करते हैं ना हम, तो Y एक्सिस में हम आप एज्यूम करो इट इज इंटेंसिटी. ओके ओके. So this is all about your spectrum. Now you can clearly see that transition, separation between two lines. That is how much. Here you can see 4b minus 2b 2b. Here also you can see that will be 2b. 6b minus 4b. You can say separation between first two lines 4b minus 2b 2b. Third and second line 6b minus 4b, that will be 2b. 8b minus 6b, that will be 4b. Sorry, 2b. So separation between two lines, successive lines, is constant, but experimentally there is a little bit variation. ठीक है, एक्सपेरिमेंटली क्या होता है, थोड़ा सा वेरिएशन हो सकता है. तो उस टाइम आपको सपोज मान लो दिस इज 2b ऑन 2b2 2b3, तो आपको नेट निकालने के लिए क्या करना पड़ेगा, या इफेक्टिव रोटेशनल कॉन्स्टेंट निकालने के लिए आपको सारे का एवरेज करना पड़ेगा, और एग्जाम में वही देता है. ठीक है, so according to theory that separation is constant 2b, and that may also ask that separation between two lines, two successive lines in rotational spectra will be 2b 4b 6b like that. So it will be always 2b. Okay, is this part clear? कोई डाउट हो तो बताओ, इसमें किसी का कोई डाउट है, किसी का कोई क्वेश्चन है? और shall I erase this part?
सर ये -1 भी हो सकता है
जी,
-1 भी हो सकता है.
कहाँ पे?
ये J प्राइम माइनस J डबल प्राइम.
J प्राइम माइनस J डबल प्राइम अगर नहीं, एक्चुअली इसको प्लस ही लेते हैं. ठीक है, माइनस अगर ये डिपेंड्स आप करता है आपका नोटेशन के ऊपर. सपोज मान लो आपने यहाँ से यहाँ फोटोन जा रहे हैं ना, तो बेसिकली ऑब्जर्वेशन के लिए आप माइनस भी ले सकते हो. अगर आप ऐसे ले रहे हो, सपोज मान लो यहाँ से यहाँ ट्रांजिशन हो रहा है, तो 0 टू -1, मतलब इनिशियल स्टेट इसको मानोगे तो 0 -1 ले सकते हो, बट इसका जरूरत नहीं है, +1 लेके कर सकते हो.
ओके.
Is this part clear? So I think you got how that rotational mechanism used to happen, right?
यस सर.
Okay. One thing I forgot to tell, that separation, if you go from first level to second level, that separation is small. When you go to higher J, the separation will become large, right? So here you have 2b separation, here 4b, then here 6b, here 8b. Okay. Shall I erase now?
यस सर.
Okay. Now that Abhishek asked, is this intensity will be same? Answer is no. So suppose same level, again I will draw this. This is your 0 level, and let us assume some arbitrary J level. So according to Boltzmann distribution law, the population ratio of Jth level and ground level will be how much? Let us assume this is your energy Eg, Ej, and this is your energy E0. How much it will be?
e to the power minus delta E by kV.
Exactly. So Nj by N0, it will be how much? Exponential minus Ej minus E0 by kVt. And E0 is how much? 0, because J is 0 there. So we can write exponential minus Ej by kVt. Okay, now you know epsilon J is how much? Epsilon J is Ej by Hc, right? And that was how much? B into J into J plus 1, right? So you can write from here, you can write Ej equals to how much? BHC J into J plus 1. We can write it, right? Because according to the definition of wave number, it is nothing but energy divided by H, and that was rotational constant to J into J plus 1. J is your rotational quantum number. So from here you can clearly see that Ej will be BHC into J plus 1. Now I'll substitute it here. So it will be how much now? It will be simply BHC J into J plus 1 divided by KVT. Okay, that is your Nj by N0. So the plot between N and J will be looking like what? So it is clearly observable from this equation itself that number of molecule will be less when we will increase that J number. So number of molecule will be high here as compared to this. The molecule will be high here as compared to this. So molecule will be high at low J because there is a exponential decay, right, with J. For a fixed temperature, if you increase the J value, number of molecule will be less because there is exponential decay. So we can draw that diagram. So this side number of molecule, this is your J. So J0, 1, 2, 3, 4, so on. So number will be looking like this kind of decay. So what you are expecting? If the molecule is high at low J, so intensity will be looking like this. So when there is a higher J transition occurring at higher J, intensity will be low. At low J, when there is a transition between 1 and 0, intensity will be high because population ratio is high here. But for when your population is high here, but when you are increasing that J value, number of molecule will be less. So obviously transition will be less. So intensity will be low. This is the expectation, right? Is this part clear to all?
Yes.
Is this part clear to all? Please respond me so that I can proceed.
Yes, sir.
Okay. But we forgot to introduce that degeneracy of J. So each J level is how many degeneracy is there? 2J plus 1, right?
Yes.
So there will be a factor here. Suppose I am giving example. This is your ground state, and ground state will be non-degenerate. There will be a single level. First excited state will be triply degenerate. Okay. So ratio of number of molecule between this and this level will be how much? It will be how much?
3.
Let us assume something. That ratio N1 by N0 will be exponential minus, let us assume some number A. ratio of number of molecule from between this level and this level, again it will be minus J, because nothing is changing here, right? J is same, everything is same here. Ratio between this number of molecule here and here, again it will be exponential minus K. I am taking this is as a, okay, because J is fixed for this level, nothing is changing. So when we'll take total number of ratio of molecules, we have to add this plus this plus this. So automatically you see 3 will come here, and 3 is nothing but 2J plus 1 for this first level. Is this part clear what I am saying? Is this part clear what I am saying?
सर
हाँ.
सर इसमें एटॉमिक में हम जो करा है 2J2 plus 1 by 2J1 plus 1
हाँ,
into to the power daily by kb.
एग्जैक्ट
सर ऐसा कुछ नहीं होगा
ऐसे ही हो रहा है, यहाँ पे भी ऐसे ही हो रहा है आपका. यहाँ पे मैं ग्राउंड लेवल को ले आऊँ तो ग्राउंड लेवल का क्या है जे, तो यहाँ पे क्या लिख सकते हो आप 2J2 plus 1 डिवाइड बाई 2J1 plus 1 into exponential this factor BHC J into J plus 1 divided by KBT, right? But for ground level, J1 is how much? 0, right?
oh, oh.
And for this level, for J level, regeneration J2 is J, right?
Yes sir.
Thus, Nj by N0, it will be 2J plus 1 exponential minus BHC J into J plus 1 divided by KB into T. So you can see that this is a function of J, or you can say that number of population equals to N0 2J plus 1 exponential minus BHC J into J plus 1 divided by KBT. So for maximum population will be observed at what J? So for maximum population del Nj by del J equals to 0. Okay, so for some J, so how to find out that maximum or minima? So I am calculating at what value of J the population will be maximum. Okay, so what you have to do? I have to differentiate with respect to J, and you have to equate equals to 0. This is the condition. Now if you differentiate it, how much you will get? N0. So first term if you differentiate, it will give you 2. Then exponential, this factor will be same. Okay, this factor will be BHC J into J plus 1 divided by KBT. Okay, now I'll keep this as a constant. I'll differentiate this part. So if you differentiate this part, so exponential differentiation of exponential is same as this, but this is not only J, you have many factor here, so you have to again differentiate with respect to J of this factor. So if you differentiate this factor, you will get 2J plus 1, because you have to introduce this J here, so it will be J square plus J. So if you differentiate this factor, it will be 2J plus 1. So what I am saying, this factor will be common. Please write this. It will be same as this, BHC J into J plus 1 by KBT. So here inside bracket, you have to mention this. And second term will be 2J plus 1. From here you will get, you already have 2J plus 1 here. So it will be 2J plus 1 whole square. And you have this factor, BHC by KBT. And of course, this exponential factor is there. So please fill this. This is same as this. Okay. Now if you take common, so how much you will get? So what will be the common here? Exponential factor will be common. So exponential minus BHC j into j plus 1 by kBt, that will be common, and you already have n0. And inside you have 2 minus 2j plus 1 whole square, okay, then BHC by kBt, that equals to 0. Since this factor cannot be 0, n0 is not 0, exponential factor cannot be never be 0, so this factor should be 0. So if you put this factor is 0, so 2 minus 2j plus 1 BHC by kBt equals to 0. So what you can get from here, 2j plus 1, that will be twice kBt. Of course, whole square will be here. Okay?
Yes.
Yes. Twice kBt by BHC. Right?
Yes, sir.
So, okay. So it means 2j plus 1 will be how much? Square root of 2 kBt minus, sorry, B divided by BHC. So it means J equals to how much? kBt by twice HCV also, you can write HCV, okay, minus half.
तो 2 तो आप आएगा ना सर ऊपर?
नहीं,
ऊपर
अच्छा, 2 से डिवाइड कर दिया
आपने डिवाइड कर दोगे तो यहाँ 4 आ जाएगा ना स्क्वायर रूट के अंदर, तो 2
तो सर 1/2 भी तो आएगा सर वहाँ पे?
हाँ एग्जैक्टली, यहाँ पे 1/2 आएगा. गुड, वेरी गुड, very good, very good. So this is the value of J at which you will get maximum population. So it depends upon temperature as well as rotational constant. Okay, very good, you mentioned this.
Okay, sir.
Okay,
Thank you, sir.
now, so how that plot will be looking like now? This side you have n, this side j, 0, 1, 2, 3, and so on. So it will look like this kind of plot. So the spectrum line will be six. So you can clearly see that that intensity is not constant. This is the intensity I have mentioned, because intensity basically depends upon the number of molecules. So number of molecules is no longer is high at 0 level. It is at some J value where population is maximum. So we will get maximum intensity from that level itself when it will make transition from that level to lower level. Okay, so that answer I already have given, that intensity is not fixed, but it will be high at some intermediate. Okay. Now only little 5 minutes theory is there, then I'll stop for a few minutes, then we will solve few interesting problems, and that will be helpful for your exam. So is this part clear to all, whatever theory I have discussed? If is there any doubt, please tell me, otherwise I'll proceed. Is there any doubt till now? Is this fine to all?
Yes, sir.
सर
हाँ.
जे अगर 0 ना हो, मतलब J to 0 ट्रांजिशन ना हो, तो ये एक्सप्रेशन होगा?
कौन सा 0 ट्रांजिशन ना होता?
सर ये तो हमने J to 0 NJ by N0 किया. अगर सर NJ by like NJ minus, हाँ सपोज J minus 2 ऐसा कुछ, तो उसका भी तो डिजेनरेसी इंक्लूड होगा,
हाँ यस,
तो
हाँ
एक्सप्रेशन
हाँ यस यस यस, एक्चुअली यू कैन डू दिस काइंड ऑफ थिंग आल्सो, बट ये आपका जो डिस्ट्रीब्यूशन है जे के रेस्पेक्ट में कैसा है, मतलब नंबर ऑफ पॉपुलेशन वैसे होगा। सपोज मान लीजिए आपका यहाँ पे आपका जे के करस्पॉन्डिंग आपको पॉपुलेशन इतना मिल रहा है ना, तो जे डैश की करस्पॉन्डिंग या जे माइनस वन की करस्पॉन्डिंग यहाँ मिलेगा, जे प्लस वन की करस्पॉन्डिंग, तो आप वो वेरीफाई कर सकते हो आराम से। सपोज मान लो आप एन जे माइनस वन लो डिवाइड बाई एन जीरो करो, इसका देखो किस तरह से होता है ना।
ओके।
समझ लो? तो आप उस वे में भी सोच सकते हो, बट यस एन जे डिवाइड बाई एन जे माइनस वन करके देखो कि पॉपुलेशन क्या हो रहा है, किसके ऊपर डिपेंड कर रहा है। But this is the best way to calculate that at what j value, or simplest way I can say, at what j value that population will be maximum. And this way you have to proceed. Many times they used to give this formula, you know, it's a very famous formula for your exam point of view also. So at what value of j that population will be maximum. Okay, you can introduce two factor also there, but it will be complicated to calculate. You may proceed. Okay, if you don't have any more question, then let me take 5 minutes discussion for your another part, that is isotopic effect. Suppose you have example C12O16 and its isotope is C13O18. So generally isotope will have large mass. So of course let us assume its reduced mass is mu I and it's simply mu. So it means mu I isotopic mass, reduced mass of isotope will be high. So you can write mu I by mu, that will be greater than 1. And we know that mu is inversely proportional to B. So what we can write from here? B by Bi. Bi is the rotational constant of this, and B is the rotational constant of this. So what we can write? B by Bi. Why it is happening? Because mu I by mu is greater than 1, and mu is inversely proportional to B. B is rotational constant. So mu I will be inversely proportional to Bi. So it will be 1 by Bi, and it will be 1 by B. So B by Bi will be greater than 1. So it means rotational constant of original molecule will be greater than isotopic molecule. So now the energy level depends upon that B, right? Ej proportional to B. So when we will draw that energy level diagram, so B is large for this as compared to this. So if you draw that energy level diagram for both, so this side you have C12 oxygen 16, and this side you have C13 oxygen 18. Okay, no need boundary here. So energy level will be at low J, there will not be that much change. But when you will go to high J, you can see there is a shift of energy level. This is for your isotope and this is for your original molecule. So there is a downward shift of that energy level. Because why this is happening actually? This is because Bi is small as compared to B. So of course the energy of isotope will be less, slightly less as compared to original molecule, because energy depends upon B, and B is greater for original molecule. So that's why energy for small j, there will be very much small deviation, but that deviation or downward shift is clear when we will go to higher level. Like from here, they have same j, but for isotope that level is downward here also. So because of this rotational constant. So this is all about your theory part. I'll take 5 minutes break, then I'll go to problem. Is this part clear to all?
Yes, sir.
Yes.